This lecture discusses how to find probabilities of a given normal random variable. This slide summarizes the steps of finding a percentage or probability for a normal random variable. First, sketch the normal curve associated with the variable. Usually, you need to mark the location of the center mu. Then, shade the region of interest and mark the delimiting x values. Pay attention to whether you need the area to the left of a value, to the right of a value, or between two values. Next, find the z-scores for the x values. To calculate each z-score, we subtract mu from x and then divide it by sigma. Last, use the standard normal table to find the area under the standard normal curve delimited by the z-scores. Let's look at one example. Assume that IQs are normally distributed with a mean of 100 and a standard deviation 16. Find the percentage of people having IQs between 115 and 140. Following the steps we just mentioned, sketch a normal curve centered at mu equals 100. Shade the region between 115 and 140. In this problem, we need to find the percentage between two values. For 115, the z-score is 115 subtract 100 divided by 16, where 100 is the mean and 16 is the standard deviation. The z-score is 0.94. We only keep two decimal places because we need to check the probability using the standard normal table later. For 140, do the same. Its z-score is 140 subtract 100 divided by 16 equals 2.5. Then find the probabilities for 0.94 and 2.5 in the standard normal table. The probabilities are 0.8264 and 0.9938 respectively. The probability of the shaded area is the difference between these two values, or 0.9938 minus 0.8264 equals 0.1674. Roughly 16.74% of people have IQs between 115 and 140. We have discussed empirical rules before. It is applicable for a variable whose distribution is bell-shaped. Basically, it means normal distribution. Approximately 68% of all possible observations lie within one standard deviation to either side of the mean. Approximately 95% of all possible observations lie within two standard deviations to either side of the mean. Approximately 99.7% of observations lie within three standard deviations to either side of the mean. The empirical rule is also known as the 68, 95, 99.7 rule. Let's check how these percentages are determined. For each value of x, mu minus 3 sigma, mu minus 2 sigma, and up to mu plus 3 sigma, we calculate the corresponding z-scores. The z-scores are respectively minus 3, negative 2, negative 1, 1, 2, 3. For each z-score, we can find the corresponding probability using the standard normal table. Then, the percentage is exactly the difference between two probabilities. For example, the percentage within one standard deviation to either side of the mean, or the percentage between negative 1 and 1. We use 0.8413 minus 0.1587 equals 0.6826. This is why we claim that the percentage is 68%. You can check by yourself the percentage within two standard deviations and three standard deviations to either side of the mean. Let's look at one example. Here, we directly apply the empirical rule to the IQs. Recall that IQs follow a normal distribution with mean 100 and standard deviation 16. Approximately 68% of people have IQs between 84 and 116. 84 is one standard deviation below the mean, and 116 is one standard deviation above the mean. Of course, you can use the standard normal table to get a more accurate value. But using the empirical rule, we can easily get an estimate reasonably good. Similarly, 95% of people have IQs between 68 and 132, while 68 is two standard deviations below the mean and 132 is two standard deviations above the mean. Approximately 99.7% of people have IQs between 52 and 148, while 52 is 3 standard deviations below the mean and 148 is 3 standard deviations above the mean. Sometimes, we may also need to find an observation corresponding to a percentage. For such a problem, we also need first to sketch the normal curve. Make sure to mark the location of the mean. Then shade the region of interest. Use the standard normal table to determine the z-scores delimiting the region. Last, find z-values from z-scores, where x equals mu plus z times sigma, where mu is the mean and sigma is the standard deviation. IQ are normally distributed with mean 100 and standard deviation 16. Find the 90th percentile for IQs. Notice that by definition, the 90th percentile means that this number is larger than 90% of values, or the percentage to the left of this value is 0.9. Check the standard normal table. There is no probability equal to 0.9. The closest number is 0.8997, which corresponds to z equals 1.28. The corresponding x value is therefore 100 plus 16 times 1.28 equals 120.48, where 100 is the mean and 16 is the standard deviation. Therefore, the 90th percentile of IQ is 120.48. 90% of people have IQ below 120.48, and 10% have IQ above 120.48. We can use Excel to calculate probabilities for given x values and calculate x values for given probabilities. To find the probability less than a x value, use the function norm.dist. Notice that for standard normal distribution, we use function norm.s.dist. For norm.dist, we have 4 arguments. Additional to x, we also need to specify the mean mu and the standard deviation sigma. The last argument is always true. The resulting probability is the cumulative probability, or the area to the left of x under the normal curve. If we know the probability, we use function norm.inv to get the corresponding value of x. The first argument, prop, is the probability less than x, or the area to the left x under the normal curve. The second argument is the mean, and the third argument is the standard deviation. In the last, let's look at another example. It is known that the body temperature of male adults approximately follows a normal distribution with mean 36.7 and standard deviation 0.4. In the following, there are 5 questions. The first 3 ask for percentage, and the last 2 questions ask for the value of x. Let's solve them one by one. What proportion of the body temperature is less than 37.1 Celsius? We want to find the percentage to the left of 37.1. Notice that 37.1 is exactly 1 standard deviation above the mean. We may use the empirical rule. Recall that according to the empirical rule, we know the probabilities for each piece on the graph. Here, we simply add the probability up to 1 standard deviation above the mean, or 84%. If we use value z equals 1 to find the probability in the standard normal table, we will get a more accurate probability, which is 0.8413. If we want to use Excel, we can directly calculate the probability using the x value. In this case, we need to use norm.dist. Make sure to specify the correct mean 36.7 and the standard deviation 0.4. It yields the same probability. Alternatively, because we have calculated the z-score already, using the z-score, we can find the probability from the standard normal distribution using function norm.s.dist, which yields the same answer. What proportion of the body temperature is larger than 37.1? In this problem, we want to find the percentage to the right of 37.1. We have already known the proportion of body temperature less than 37.1. 1 minus that probability will yield the answer to this question. However, here I still list the detailed steps for each possible approach. You may study this slide by yourself to make sure that you understand it. What proportion of the body temperature is between 36.3 and 37.1? This question asks for the percentage between 2 values. If you notice that 36.3 is 1 standard deviation below the mean, and 37.1 is 1 standard deviation above the mean, you can apply the empirical rule to claim that approximately 36% of the body temperature is between 36.3 and 37.1. Using the standard normal table, we can get a more accurate answer. The z-scores of 36.3 and 37.1 are -1 and 1, respectively. Using the standard normal table, we find that the corresponding probabilities are 0.1587 and 0.8413. The probability is therefore their difference, or 0.8413 minus 0.1587 equals 0.6826. We can use Excel to evaluate the probability directly. Norm.dist 37.1, 36.7, 0.42 calculates the cumulative probability for 37.1. Norm.dist 36.3, 36.7, 0.42 calculates the cumulative probability for 36.3. Their difference yields the answer to this problem. Equivalently, we can calculate the probability in terms of the standard normal random variable, which yields the same answer. Find the lower quartile of the body temperature. The lower quartile is the 25th percentile. The area to the left of this number is 25%. We need to find probability 0.25 in the standard normal table. However, there is no 0.25 in the table. The probability slightly smaller than 0.25 is 0.2483 when z equals negative 0.67. The probability slightly larger than 0.25 is 0.2514 when z equals negative 0.68. 0.25 is roughly the average of 0.2483 and 0.2514, not exactly, but close enough. Then we claim that the z-score corresponding to probability 0.25 is negative 0.675, which is the average of negative 0.67 and negative 0.68. Last, calculate x value from this score. The temperature is 36.7 plus 0.4 times negative 0.675 equals 36.43. The lower quartile of the body temperature is 36.43. We can calculate the lower quartile directly using the Excel function norm.inv 0.25, 36.7, 0.4. If using function norm.s.inv 0.25, we will get the z-score. It is negative 0.6745. You can see that it is close to the value we obtained from the standard normal table. Next, we still need to calculate the x value using this z-score by hand. Find the value x such that 95% of the body temperature is at most x. This value is exactly the 95th percentile. The area to the left of this value is 0.95. First, we need to find probability 0.95 in the standard normal table. There is no 0.95 in the table. The probability slightly smaller than 0.95 is 0.9495 when z equals 1.64. The probability slightly larger than 0.95 is 0.9505 when z equals 1.65. The value 0.95 is exactly the average of these two probabilities. Therefore, the corresponding z-score is the average of 1.64 and 1.65. So the z-score is 1.645. The x value is therefore 36.7 plus 0.4 times 1.645 equals 37.358. The 95th percentile of the body temperature is 37.358. If using Excel, the value can be calculated as norm.inv 0.95, 36.7, 0.4. So the value is 37.3579. Alternatively, you can calculate the z-score as norm.s.inv 0.95 and then calculate the x value by hand.